Hello and assalamualaikum students. Welcome to another video of study with ARS, and today's our topic is chapter number 1. We will be covering all the important topics. Not all the important topics. We will be covering all the topics which will be coming in your test, and which are means highlighted topic which used to come in every of the test. So it will be making you test. It will make your test better. So starting with the first topic, so we have the topic named as accuracy and precision, and we know that there are other topics which are before than accuracy and precision, but first of all we will be going with an important topics. Okay, so without wasting time, I am defining accuracy. So accuracy is defined as that it is the closest value to the experimental value or you may define as that the nearest value of experiment towards the actual value is known as accuracy, or you can also define as that the difference between the nearest value of experiment and actual value is called accuracy. So the in mathematically you can also write this like this: nearest towards the actual value, nearest experimental value towards the actual value. When we will be subtracting these both, and the answer will be accuracy. So accuracy is inversely proportional to error. So now you might be thinking that what is error. So error is a mistake made by a person or instrument or an environment. So there are three types of error. Number one is personal error, number two is random error, and number three is instrumental error. Personal error is will happen because of the mistake from the person who is taking reading wrong, who don't know that what is period, what is the instrument, he don't know that how to calculate it. So it is the error which held because of the person will called personal error, and the other one error is random error, the error which will be happen through the means through the temperature of environment, means because of the environment any error is there, then we will be saying that the error is random error. So the last one error is instrumental error. It used to it happen because of the means instrument, if instrument is not good, then a person error could be happen there. Okay, so the other topic is precision. So the precision is defined as that it is the smallest difference between the only experimental values is called precision. And for example, here we are having five names. So one is Ali, second is Sarah, other one is Hassan, and Shoaib and Salim. So these are the students who went to means chemistry lab and went to get readings in titration. So the actual value was not in titration specifically in any of the experiment. Okay, so the actual value was 9. Okay, so when they go there and then they take out their readings, so Ali was having 8.6 reading, Sarah was having 8.7 reading, Hassan was having 8.8, and Shoaib was having 8.9 reading. But Salim was having 8.2, which is far away from Ali, and it because of it is means very away from the Ali's value. So we will be saying that it will be not be calculated in precision. We used to calculate only the small difference between the only experimental value. So when we will be taking the average, so first of all we will be doing average, we will be uh, taking out the average of these value, but before that we have to subtract it. For example, uh, the difference between these two is 0.1, and difference between these two is 0.1. So like this we will be taking out the average. They do not go at this side is wrong. Okay, so here we are having the value of Salim, so it will not be calculated in precision. So we are having the example of accuracy which we have defined here. So here is the example of accuracy, and it is like this, where that actual value is 7, and some student were there and who got the value 6.4, 6.5, 6.7, 6.9. So the nearest value from these all are this one, 6.9, and it is the nearest value. So we will be subtracting this value from 7, because the 7 is the actual number. So when we will be subtracting, then we will be getting 0.1, and this 0.1 is known as accuracy. So the next one topic we are having is scientific notation, and in scientific notation we are having the definition. So definition is this, that to write a bigger value into a smaller space. For example, we are having mass of earth. So the value of mass of earth is 6 and 24 zeros. So it is a bit means difficult for us to write this one bigger value in this space, because we are not having that much space to write it. Because of this, we can also write it like this, and this 10 represent the zeros. So the after this, we are having the example of scientific notation, which is 400 4001 one, 10, 100,000, 10,000, 41,826. So if we want to convert it into scientific notation, so we will be moving point towards the left side. So remember one thing, if the point is moving towards the left side, the power will be in the positive sign. If the point is moving towards the right side, then the point will be in the negative sign. Okay, so the point now has been moved to before the first value, and because it moves towards the left side, then we can write it like this: 4.186 into 10 is power 4. So we are not need to write this whole value 4.1826 into 10 is power 4. So we can also convert it into like this: 4.1 into 10 is power 4. Okay, so this was the topic of scientific notation. Let's go for logarithm. So the first definition, we are going towards the definition. So the definition is this, that the process or method to divide or multiply the number which are having scientific notation, or they are in complex form, means they cannot divide by the simple mathematics rule. So we will be using logarithm. So example of logarithm is this, like this, we are having question, so we cannot solve it by only the simple algebraic method. Okay, so that's why we are having logarithm. So the question for logarithm is, you can take a screenshot, because I will not be defining whole the question. I will just be defining according to the rules. Okay, so we are having 4 rules of logarithm, and number one is rule is this, that log a into log b will be equals to log a plus log b. Okay, if the two values are multiplying, then we will be converting into 8 by adding them uh, and we'll be writing log on both sides. Okay, on both bases. Okay, then we are having log a divided by b, then we can also convert it like this: log a minus log b. And we are having log a and exponent is n, so we can also write this exponent before the log, like here we have written. So the last one rule is this, that if any value is in radical form, so as you know that the power in radical, this one power is in radical will be going towards the side, and it will be converted into 1 upon and the power, which is so log radical a power log radical n, and a is here, so it will be converting 1 upon n log a. So here we are having the question. So first of all, we will be taking log on both sides, log x, because nothing is here, we can write x, and we will be writing the all the values. Then we will be converting the multiply into plus, and now we have come completed this one rule. So now we are going towards the division rule. It is dividing, as you know that in fraction form, if means denominator is there, so it means it will be dividing. So instead of dividing, we can write this one sign. This is minus. So when we will be writing this, then we will be moving power before the log, and then we will be taking out the log, and then it is a simple calculation. And after that we are getting the answer of 3.9 3.898. Then we will this one log will be shifted toward this side. So this one log will be shifted toward this side, and it will be getting inverse sign. So as you know that log inverse is also equals to anti-logarithm. So when we will be getting the answer of log inverse or anti-logarithm from the calculator, then it will be like this. So we will be converting into simple scientific notation, which is like this: 7.9 into 10 raised power 3. So here we have completed the logarithm topic. So here we are having another topic which is known as significant figures. It is the most important topic in chapter number 1. Okay, so the definition for significant figure is this, that it gives contribution in measuring any value. So it is also known as important numbers, because significant means important. So here we are having six rules of significant figures. Okay, all non-zeros are significant figures, zeros between non-zeros are significant figures, zero after decimal are significant figures, zeros on the left are non-SF, zeros on the right without decimal are non-SF. Scientific notation, only numbers are SF. So here are the examples of these rules. Hope you guys are understanding all the things. So here we are having example 489. So there are only non-zeros. According to the first rule, there are 3 SF, and according to the second rule, there are 4 SF. This one rule, the zeros between non-zeros are SF. Okay, there are 4 SF, and according to the third rule, there are also 4 SF. This one rule, zeros after decimal are SF. So after decimal, these zero will also be calculated in significant figures. So we are having this one 0.036. So according to the fourth rule, which is this, that zeros before the decimal are non-SF, and before the non-zeros are non-SF. So because of this, there are only two SF are present. And then according to the fifth rule, which is here, zeros on the right with not decimal point are non-SF. Then zeros on the right, these are on the right, but without decimal point, these will be not calculated in significant figure. So there are two SF, only 9 and 8 are SF. So here we are having the sixth rule, which is this, just only scientific notation. Only the exponential value will not be calculated, which is into 10 raised power x maybe. So in here we are having 6.4 into 10 raised power 6. So here this one exponential value will not be calculated. So here we are having only 2 SF. Okay, so now we will be going towards this one topic, changes and empirical formula. And this one topic is also important for you guys for any test or anything. So here we are having, first of all, chemical change or chemical reaction are both the same things. Okay, so here it is, the definition is this, that a chemical change which forms a new product in the result means, if it is forming a new product, for example, if hydrogen is there and reacting with oxygen, then it will be forming H2O. It is a common example, it is a very easy example for this chemical change. So here we are having the example of this chemical change. Burning of paper, as you know that burning of paper will be in the chemical change, because of the combustion reaction, oxygen in the presence of oxygen, paper will be burning. Okay, and then we are having C carbon plus oxygen equals to CO2, which is a gas. And now we are having NaOH, sorry, we are having H2O plus NaCl. H2O is water, NaCl is stable salt, and it will be means forming HCl, which is a strong acid HCl, and NaOH. It is a alkali. Okay, and then we are having uh, physical change. So here we are having the definition of physical change. The change in which thing which is converting from one form to another, that change is called physical change. Okay, so here we are having the example: ice, water plus steam. Ice converted into water, water converted into water, steam. Okay, so in all the things there is H2O. Water is also H2O, ice is also H2O, and steam is also H2O. So because of this, we will be calling them as a physical change, because no new product is forming here. So after that we are having the formula. After we are having the empirical formula, which is also an important topic. Simplest whole number ratio of any compound or molecular formula is called empirical formula. For example, we are having glucose, which is an organic compound. When it will be in this form, then we can call it molecular formula. Okay, then when we will be means dividing this, the 6 1 is 6, 6 1 is 6, 6 2 is 12. Okay, then here we are having this one is the empirical formula. Okay, in this one is the empirical formula. This is the empirical formula of this one, glucose. Okay, CH2O, oxygen, O for oxygen. So we are having the another topic, which is difference between atomic mass and mass number. So this is the topic in which all the means you may say all the student of this world are confused, because no one can give, at least Google cannot give the proper reason that what is the difference between atomic mass and mass number. But I am here to clear your confusion. So here we are having these both topic, atomic mass and mass number. So atomic mass is defined as that it is the average mass of isotopes. As you know that they are having same atomic number but different, they are having uh, different atomic number but same atomic masses. Okay, so they are called isotope, and isotopes are means only the change in same atomic number and different atomic masses are called isotope, and isotopes are only in the changes of neutron. Okay, so the average mass of isotope of an element, called atomic mass. So as you know that hydrogen is having three isotope: hydrogen itself, protium, deuterium, tritium. So when we will be calculating the mass of hydrogen, so then we will be taking out the average of all these all the atomic masses of the isotopes of hydrogen. Then we will be getting this one, all when we will be calculating the average of all the mass number of protium, deuterium, tritium. Then we will be getting this one, atomic mass 1.00784 AMU. This is the atomic mass unit, and this one is the atomic mass of hydrogen, this one. So mass number is defined as that it is the specific mass of an element, or you may say of an substance, because it is a specific, it will be a specific mass of that particular that particular element, or you may say atom. So like we are having tritium is an isotope of hydrogen. It is a radioactive isotope of hydrogen, and it is having two neutron in it and one electron. So the mass number of tritium is 3. So this 3 is the specific mass of this one, tritium. So hope you guys enjoyed this one overview, and if you like it, then comment down below that I should make this type of videos. Thanks for being here, and we'll see you in the next video.